Welcome to question 9 of the 2010 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 9 we're told that part of the graph of f, which has the rule x log e of x, is shown below. For part A we're asked to find the derivative of x squared log e of x. So the first thing that we can note is that this is two functions multiplied together, so we can use the product rule for differentiation. So to apply the product rule, we're going to use u is the first function, x squared, and v is the second function that's multiplied, so that is log e of x. And then we calculate the derivative du dx, which is going to equal 2x, and dv dx, the derivative of log e of x, which is 1 on x, and we can use the formula sheet to help us find those derivatives. So on the formula sheet we're told that the derivative of two functions u and v multiplied together are equal to u times dv dx plus v times du dx. So therefore the derivative that we're after, so d dx of x squared times log e of x, is equal to u, which is x squared, times dv dx, which is 1 on x, plus v, which is log e of x, times 2x, which is dv dx. And now simplifying that down, we have x squared times 1 on x, well that's just x, plus, and this is just 2x log e of x. So that is the expression for the derivative that we were asked to find. In the examiner's report, it shows that this question was completed correctly by the majority of students, or around 75% of them. For part B of this question, we want to use our answer from part A to find the area of the shaded region in the form a log e of b plus c, where a, b and c are non-zero real constants. And now the reason why we need to use our answer from part A is that we don't know how to integrate x log e of x directly. Instead, we need to use integration by recognition to do that. So we're going to start this problem off with a statement. And that statement is that the derivative d dx of x squared log e of x, and that is equal to x plus 2 times x log e of x. And you can see that I've put that in purple because that now matches the function's rule of f of x, which is the curve which we're trying to find the area under. Now if we integrate both sides of this with respect to x, we'll find that that now contains the integral that we're after, and we've just got to do some manipulation of this to get it by itself. So next we can start to work with the statement that we've just created. So the integral of a derivative, we know they're inverse operations, so they undo each other. So on the left hand side, we're just going to end up with this inside bit, which is x squared log e of x. So therefore we find that x squared log e of x is going to be equal to, and on the right hand side we can integrate this term x by itself. So the integral of x is x squared on 2, and then we're going to have 2 times the integral of x times log e of x dx, which is what we wanted in the first place. And at this point I'm going to include the terminals of 1 and 3, which is where we want the area between. So there's a couple of things we're going to do in this next step. The first thing is we're going to rearrange, and that's to get the x log e of x integral by itself, and as part of that we're going to need to divide by 2, and that's because there's currently a 2 multiplying that integral. So therefore we find that the integral between 1 and 3 of the function x log e of x dx is equal to, and we're going to put this in square brackets because we're still going to have our terminals at this point, and we already had x squared log e of x and we need to divide that by 2, so we can write this as x squared over 2 times log e of x. And then we needed to subtract away the x squared on 2, which is on the right hand side, but halving that will now give subtract away x squared on 4, and the terminals are between 1 and 3 still. And now to evaluate that integral we're going to need to substitute in the upper terminal, which is 3, so 3 squared on 2 will give us 9 on 2 log e of 3 minus 9 on 4. And then we subtract away the lower terminal substituted in, so that's going to be 1 squared on 2 is just 1 on 2. Log e of 1 minus 1 squared is 1 on 4. And now we just need to simplify this so that we have it in the form a log e of b plus c, which is what the question requires. So first of all, we need to look at this log e of 1 and realise that log e of 1 is actually 0. So we're going to have a half times 0 there, which is simply 0. Which means this is equal to 9 on 2 log e of 3. And then we have minus 9 on 4, subtract negative 1 on 4 is a plus 1 on 4, which gives negative 8 on 4, which is simply negative 2. So hopefully you followed along with that, and you can see that this is the final answer in the form we wanted it in. So from the examiner's report, we can see that 20%, or around 1 in 5 students, got this fully correct, and just over half of students got no marks for this question. So they didn't even set up an integral statement that could have been considered working for this question. And the examiner's report goes on to state that few students who got the correct answer for question 9a, which was quite a few students, could actually complete this question. And the most common error along the way was not dividing everything through by 2, which we made a big deal of on the last slide.